All right, we are going to start these reciprocal functions by just graphing this one, just kind of a warm-up. This is a pretty basic function, 1 over x. The reason it's called a reciprocal function is because normally we deal with x's that are in the numerator, so this is the reciprocal. We've got the x in the denominator. So I've got a table of values, but we want to plug in -4, which is going to give us -1/4. And then we'll plug in -3, so -1/3. Hopefully you can see that's what we're plugging into. -1/2. And if I plug in -1, I get -1. Now, when you start graphing this, -4, -1/4, -3, -1/3. Okay, this is kind of what it looks like so far. I'd really like to see what's happening a little bit closer to 0, because if we just plug in those numbers and skip to plugging in 0, well, 1 divided by 0, that's undefined. We can't do anything there. But I've included a couple other points for us so we can take a look at it. So if we plug in 1 divided by -1/2, remember that when you divide by fractions, it's the same as multiplying by the reciprocal. So this is the same thing as 1 times -2/1. That's a negative, which is just going to be -2. So -1/2, -2. All right, and then when we plug in -1/4, that's 1 divided by -1/4. When we divide fractions, we multiply by the reciprocal, so this is 1 times -4/1, which of course is -4. So -1/4, -4. Same process, if we do 1 divided by -1/8, multiply by the reciprocal, we're going to get -8. So, boy, that doesn't even fit. It's down here somewhere. Okay. So let me erase that stuff. Don't really need that there. Okay, let's keep going. We can't plug in 0. We had said that's undefined, so whatever. 1 divided by 1/8. Well, when we divide fractions, that's multiplying by the reciprocal, so this is 1 times 8/1, which is going to be 8. 1 divided by 1/4 is going to be 4. 1 divided by half would be 2. And then we're getting into numbers that are easier. 1 divided by 1 is 1. 1 divided by 2 is 1/2. Are there more here? No, no more. 1/3 and 1/4. Okay, so we get 1/8, 8. That doesn't fit on here. 1/4, 4. 1/2, 2. 1/1. 2/2, 3/3, and so on. Okay, so hopefully you can tell from this graph what's happening. This looks like this. It's kind of going down, and it keeps going down, and it keeps going this way. And the same thing's happening the other direction. Okay. So a couple of key terms. This should look familiar because you did it in Algebra 1. But notice there is nothing here. We could not plug in 0. So we call this a vertical asymptote. Vertical asymptote. Also, in this direction, notice we are never going to get 0. There is nothing that 1 divided by, there is no number that you're going to get 0, even if you do 1 divided by 10 million. It's just a teeny tiny number. It's never going to actually hit 0. So we call this a horizontal asymptote. Okay, and those asymptotes provide the structure for the graph. Asymptotes are things that the line gets closer and closer to but never actually touch. Actually, that's not always true. Sometimes horizontal asymptotes get crossed. We will talk about that tomorrow. But the basics of reciprocal functions. All of the functions that we're going to deal with today revolve around this. I encourage you to check this out in Desmos. Like, you can plug it in and put sliders in so you can see exactly what's happening. But let's talk about domain. You can plug in anything you want into this function, except we can't divide by 0. So if you plug in h, that would give you h minus h, which is going to give you 0. So it's all real numbers except x cannot be h. Okay, so any number that's going to cause you to have 0 in the denominator is not part of the domain. What that means is you are going to have a vertical asymptote at h. The range. The range is also going to be all real numbers except whatever is over here. Okay? Remember, we can't take our number divided by something. When we did 1 divided by 10 million, we still got really close to 0. If we've got something added on the end, that's going to be it as well. So the range is all real numbers except whatever k is, which means that k is going to be your horizontal asymptote, but that's going to be the line. The a on the top, that's just a number, okay, that determines kind of like the steepness of those curves that we saw. Also, if that's a negative, instead of the curves like in the last one up there, the curves were here and here. If it's negative, that switches the curves to being here and here. And like I said, it can also kind of change the steepness of it. So that's what A does to these problems. So in the next video, we will actually use this information to find the asymptotes and to get a really good graph. But just remember, this is telling you your vertical asymptote, and this is telling you your horizontal asymptote.